Hello everyone, welcome to new class. Today's class is about the working of PNP transistor and NPN transistor. So let us study about the working of PNP transistor. So this is the basic connection of PNP transistor and consider the action of a PNP transistor whose emitter base junction is forward biased and collector base junction is reverse biased. That is, this is P. So emitter is forward biased means this is positive and this is negative, and that is reverse biased, and a large number of majority carriers in the emitter. So in emitter, what is the majority carrier? So this is P. So the majority carriers in P region is holes. So the majority carriers in the emitter and electrons in the base. So the majority carriers in the base is electrons. So these majority carriers will diffuse across the forward biased PN junction. Hence, the total current flowing across this junction is the sum of hole diffusion current and electron diffusion current. And this total current is called the emitter current IE. Since the central region, that is the base, is very thin and lightly doped, the majority carriers that start from the emitter get very little chance to recombine in the base and cross the base region to reach the collector. Only a few majority carriers are lost due to the recombination. In practice, about 2% of the majority carriers which diffuse into the base recombine with the electrons, and the total loss of the number of electrons is made up by the flow of an equal number of electrons from the negative terminal of the DC battery VEE to the base, and the flow by such electrons constitute the base current IB. Hence, the magnitude of the base current IB is very small and is of the order of microamperes. So, IB is in microamperes. The potential VCC in the right hand section is such that the carriers reaching that section get easily attracted and a current starts flowing. So these holes are attracted towards this. So a current starts flowing and this current is called collector current IC. And the collector current has also a second component of current, and this current is due to the minority carriers called the reverse saturation current, also called the leakage current ICBO. And this flows through the reverse biased collector diode. Hence, the collector current IC is the sum of leakage current and remaining emitter current. Next is the working of NPN transistor. So here the emitter base region is forward biased and the collector base junction is reverse biased. So here this is N, P, N. So here the majority carriers are electrons, here holes and here electrons. So here this is forward bias. So these electrons will move towards this junction. So this is the current flow. That is, this arrow indicates the current flow. So the forward bias VEE causes the majority carriers in the N-type emitter to diffuse into the base, and holes from the base diffuse into the emitter. And the flow of majority carriers constitute the emitter current IE. As these electrons flow through the p-type base, they tend to combine with the holes. As the base is lightly doped and very thin, only a few electrons combine with the holes to form the base current IB. And the remaining electrons cross over into the collector region to constitute the collector current IC. So this is the collector current IC, and this collector current is also called injected current because this current is produced due to the electrons injected from the emitter region, and it is clear that the emitter current is the sum of collector current and base current. That is, collector current plus base current is equal to the emitter current. That is, IE is equal to IB plus IC. Also, we have IC is equal to beta into IB, where beta is the current gain of the transistor. So, from this, we can write beta is equal to IC divided by IB. So, that is about the working of PNP and NPN transistors. So, thank you for watching the class. If you like the classes, please like, share and subscribe my channel.